of the first 20 terms of the geometric series. So it's geometric. R is 1/2. G sub 1 is 64. So I'm going to use S sub n equals G sub 1 times 1 minus R to the n over 1 minus R. So if I want to do the first 20, that's 64 times 1 minus 1/2 to the 20th over 1 minus 1/2. And I got about 128. You guys get that?
Yeah.
All right, awesome.
Wait, is it okay if I use sigma?
Yes,
Oh,
you
yeah.
could use sigma. Now, in A through D, it says determine the convergence, divergence of each geometric series below and find the sums for the series that converge. So, these happen to all be geometric, but on your homework tonight, I'm going to mix up arithmetic and geometric and other types, and you've got to stop and figure out which do you have and what do you do. So in this case, in letter A, what's R? 3. So does it converge or diverge? Diverge. So you're not finding anything then. How about in letter B, what's R? 5, 4. So I would like to see on a quiz or a test that you find R and not just write diverge so that I know how you figured it out. Letter C, what's R? -1, diverge. And so I want you to look back at the chalkboard. I left it up from going over that homework problem. When we say R is between -1 and 1, it's not equal to. When it equals 1 or it equals -1, it's going to diverge. All right, letter D. What was R here? 1/10. So this one's going to converge. We're going to use S sub infinity, or just S, equals G sub 1 over 1 minus R. The first term is 3/10 over 1 minus 1/10. That's 3/10 over 9/10. That's 3/9 or 1/3. But I think you can sort of figure that out, right? Can't you figure out that that is 0.3 repeating?
Yeah.
And we change colors here. Let's go to summation notation. G sub 1 is 3/10. And you remember, you can write an explicit formula to plug into summation notation. Okay, so I'd like you to write this down so you have this. So if I say G sub 1 is 3/10 times 1/10, let's say to the n minus 1, and n will run from 1 to infinity. So this is a repeating decimal. This is actually 0.3 repeating is 1/3. So now I'm actually ready to start today's part of the lesson. Example 1 says, here's a cool application. Express the repeating decimal, 0.7 repeating, as a fraction. So when you're asked to do this on the test next week, even though there is a pattern and you can get the answer, I want you to demonstrate that you understand how to use infinite geometric series, okay? So this method that I'm showing you is the method I want you to demonstrate on the test. So here's the thing. 0.7 repeating is 0.474747 forever, okay? How do I write that as a fraction? Well, the 0.47 is 47 over 100. Then the next 47, that's not over 1,000, but actually over 10,000. And then the third pair of 47, I'm going to now have 1, 2, 3, 4, 5, 6 zeros. So what is R here? What am I multiplying by to get the next fraction? 100, right? 1 over 100, and I have G sub 1 is 47 over 100. So watch this. This is really, really interesting. If I use G sub 1 is 47 over 100, 1 minus R, that's 1 minus 1 over 100. So that's 47 over 100 over 99 over 100. And something I want to point out to you is there is a pattern, but if you're not processing this, then when we get to one of the more challenging problems, you'll be stuck because you're like, oh, it's always this. Well, it isn't always this. It isn't always over 9 and 99 and 999. The majority of the time it is, but not always. So I really need you to focus on the process that we're going through because you'll see it on the back, okay? You'll see why I'm trying to do this. So this is 47 over 100. When you divide by a fraction, you multiply by the reciprocal. The hundreds cancel, and I get 47 over 99. So what I would like you to do is I'd like you to flip this over, and I want you to try A, B, and C. But I need you to look carefully at letter C. C is not 0.16161616. This is 0.1, and then only the 6 repeats. So then that's why, if you're understanding this, you should be able to do part C. If you're just looking at, oh, I'm going to stick it over 9 and 99, then you're not going to understand. So let me pause a moment and let you guys try. I expect everybody to be able to do A and B, and I might need to help you with C. Alright, I'm going to go ahead and start. In letter A, if I have 0.5 repeating, so that's 5/10 plus 5 over 100 plus 5 over 1,000, and so on. So the first term is 5 over 10, and R, I'm multiplying by 1/10. So there's infinitely many sums. It's geometric. So this is 5 over 10 over 1 minus 1/10. So it's 5/10 over 9/10. So like I mentioned, the majority of the time there is this pattern going on, but you'll get stuck when you hit letter C with that. Letter B, this is 0.83, 83, 83, and so on. So that's 83 over 100 plus 83 over 10,000. I'm only going to do 2 terms. So G sub 1 is 83 over 100, and R, because I have 2 decimals that are repeating, that's 1 over 100. So if I'm adding these together, so that does end up being 83 over 99. So if you're thinking, hey, I don't need to do this anymore because it's either 999, 999, then you're going to get into trouble. And letter C, this is 0.16666 and so on. The correct answer is 1/6. Did anybody get that and would be willing to share how you thought of it? Okay, well then I'll help you. So the thing is, what you want to do is this is 0.1 plus, and then I've got the 6's that are repeating, okay? So what I did is I said, all right, that's 1/10 plus 6 over 100 plus 6 over 1,000, and so on. So when I do my infinite sum, I'm going to leave the 1/10 out, and we're going to add it back in when we're ready. So this one, R, I'm still multiplying by 1/10, but G sub 1 is 6 over 100. So my sum is going to be 6 over 100 over 1 minus 1/10. And then we're going to kind of add that together when we're done. So do you understand that? The 66666 that's repeating, that's the only thing that's going to go in my sum of an infinite geometric series. So this is going to be 6 over 100 over 9/10. So 6 over 100 times 10 over 9. Well, that'll reduce, this reduces, so I get 2 over 30, which is 1/15. So you're going to take 1/10 plus 1/15. The common denominator of 10 and 15 will be 30. So let me build that common denominator. So I get 3 over 30 plus 2 over 30, which is 5 over 30, and that reduces to 1/6. And of course, you could take out a calculator and just verify